Hey guys, welcome back to the channel. So today I'm going to show you a quick and easy way of running performance tests on gRPC services. And as always, we'll be using the root guide service that we have used on the previous tutorials. And for this tutorial, we're going to do a performance test on one of the methods, the getFeature method of that root guide service. So here you're looking at my screen. Now you can see I have Fint running. And there is the root guide service that we had. And so we can see here, these are the methods of that root guide service. They are the get feature, and then the async version of that get feature, the list features method, which is the server streaming method, record root, which is client streaming, and then root chat, which is the duplex streaming. For this tutorial, we're gonna do the performance test on this get feature async method. Okay, so let's close this. Let's close this window and let's create a performance test. Right, so to create a performance test, you have to go to the performance menu, and also over here you can see which performance test you have. So you can see I have one now, but let's go ahead and create a new one. Let's click on performance test. I have a bunch of this here. Let me just go ahead and delete all this that I've been playing around with. Yep, let me just go ahead and delete that. Okay, so now let's create our performance test. So for that, we have to click on the create button over there. And this brings up a dialog where you can enter some information about your test. So let's say get feature async. And for this test, we're going to do a constant load. And let's just put in some description over here. And of course, for the client type, Fin supports gRPC, REST, and WCF, but we're testing gRPC service, so we'll select gRPC. And we go ahead and select the root guide client. Okay, now that I have that selected, now I can see all the methods of the root guide client. So let's select get feature async and click go. All right, so there it is. So now we have our performance test created for the root guide service and the get feature async method. So let's click to open that. And here we see some of the, here on this left panel, we see the parameters that we can configure for this test. Let me go ahead and collapse this menu for a while so that we got more space. And you can see here on the load type, there are three different load types you can create. First one is a constant. It just means that we create a fixed number of virtual users. And with this, each user will just repeatedly invoke that the method of the service. We could also choose incremental, so that would mean we start off with 0 users, and then depending on the ramp up, so here in this case 1000 milliseconds or 1 second, so we will create 1 user every second until we reach the target number of virtual users over here. Or you could also do a burst test, so which the configuration is the same for the others, but you have 2 new ones here at the bottom, the burst duration and the burst interval. And this one is appropriate for scenarios where you have a service where you know that the load on that service is not even, where there, for example, there are times during the day where there are peaks where the service is being used, and then there are a lot, and then there are times when it's almost not being used. So you can configure, so these bursts of activity you can configure using this burst test. But for this test, we'll just do the constant load. So let me go ahead and select again the constant load test. And let's configure this to have, let's start off first with say 1 user so that we know what to expect. Just go ahead and save this. And here we can see this, the details tab. Let's click over to the input tab. So we can configure now the input to the get features method. So here the get features method is here, and let's configure the request. Latitude, Okay, so we need the latitude and longitude values. So let's go ahead and choose some valid longitude and latitude values from our route guide service database. So I'll open up Visual Studio, and you can see it's somewhere around here. Route guide, that one, the JSON file over there. So let's just randomly choose a latitude and longitude value. So this is the latitude, just this, and then the longitude value. Let's copy that and paste it over here. Okay, go ahead and save that again. So now we have, so it's typical for running performance tests. You need to warm up your service for a while, so that all those initialization it's gone and it doesn't affect the measured values that you will be getting during your actual performance test. So to warm up the service, so let's call it with just one virtual user. Let's just configure this test with one virtual user, and let's have it set the invoke interval to 0. 0 here means that when when it makes a request to the client, as soon as the response comes back, it immediately makes another request. So there's no pause between the requests. And let's configure the duration to say 30 seconds. I think should be enough. And that should warm up the service. Let's see if that's saved, and then let's run it. Okay, before we run it, okay, I have my service running over here. So it's listening on port 5052. And before I click that run, let's see what the service does. It's actually pretty simple here on the route guide implementation service. This is the get feature method. We have a very simple console.write, so it writes a dot so every time the method gets called, we will see a dot that goes on that moves on the console screen. And then it just runs this check feature call, which should be very fast because it will be querying an in-memory database. Let's go back now. So this is our service running now for port 5052, and let's go back to Fint and let's start warming up the service. Okay. I'm going to click on the run method now. Click that, and let's click back to the service. Now we can see that you see that now the dot running across the screen. Now we know that Fint is now repeatedly now calling this service. So the dot moves very fast because we set our invoke interval to 0. Okay, so let's the test. Okay, now it's all done. So we set it to 30 seconds. So elapse is about 30 seconds too. And now the dot stopped moving, and the graph start moving. Stopped moving too. Okay, I think that should be enough. So we can start it now with an actual performance test. So let's see. Oh, I should have clicked constant and save. So now let's do let's start off first with 10 virtual users, and then let's set the invoke interval to typically, if you're gonna simulate like your real service, maybe half a second, and then we set our duration to about let's say about 5 minutes. So 300 seconds is, oops, that didn't go yet. 300 seconds, and then let's save this. Yeah, so 300 seconds, the tooltip didn't update. 300 seconds is 5 minutes. All right, and then over here, as we all know, you can see that when we warmed up the service with just one user, we now have some of these values over here. So just briefly, before I start the test with 10 users, we can see here on this, there are some metrics over here, the main ones. So you have the average, median, minimum, maximum, and so on the rest of the other metrics. And then over here at the top, you have 3 charts. It will show you the response over time of each of the calls to the service, and then there's a the rate or the throughput for the responses that we're getting back, and also some distribution of the responses that we're getting back from the service. Okay, so notice that with previously with one virtual user, the calls are going really fast. So it's 1.68 milliseconds is the average. But we should expect now that we're running 10 users, we should expect this to go up because the service, the gRPC service, will have a little bit more work to do. So we won't be able to serve each request that fast. Okay, so let's see. Let's go hit, I'm gonna hit the run method now, the run button. And let's go back to our service and let's see if it starts running. There we go. Now that's moving. So this time it's moving a little bit slower, the dots, because we've configured the invoke interval to be 0.5 millisecond. And also, if you kind of wait a while, the service kind of slows down again. So let's stop this and retry that again. Just click on run. Then nope, that's running again. You can see now we have better values now. So average is 3 milliseconds, pretty close to the median time, which is about 2 milliseconds, so 1 millisecond difference. And recall that the average when we only had one user, it was around 1 point something milliseconds. So now that we have 10 users, so it's getting slower, definitely. And over here, you can see the graphs. You can click on this zoom level, so you can follow along as the test progresses. Okay, and okay, so now some over here, the median, for example, now our average is about 42 milliseconds, and the median is still pretty low. So the server is not doing really well because of that one big spike over there, which is about like around 5.2 milliseconds, 5.2 seconds. But some metrics that we could see, if you hover the mouse on the median, it also shows you the percentile. So at 95%, percentile is currently it's at 9 point something milliseconds. So that would mean 95% of the requests fall below 9 milliseconds. So actually, the service is doing fine because it's still serving requests, majority of the requests below 10 milliseconds. It's just that we had that spike, so that brings up the average. Okay, so we have about we have made about 2,000 requests, and over here as well. I'm going to stop this test now. And over here we can see the distribution of the response time, and this response time distribution is based on the 95th 95th percentile. So all these requests fall below the 95th percentile, which is currently at 8.95 milliseconds. So this should be around that. So 8.95 is 9 milliseconds rounded off. So all these requests over here are in the below the 95th percentile. And we can see that actually the majority of the requests uh, finishing up with about 1 millisecond. So between, so for example, for this bar over here, which is about 19, is at 9, so 19% of the requests uh, was less than 1.3 millisecond, and we have 22% of the request was between 1.3 to 1.7 milliseconds. So service is doing pretty well, although we had that spike over there. So you can also save this test, and you can click on save, and then it will save the results of that test. So let's go and click. So I've clicked on save, and I open that, and then if I open that again, so you'll get back the results of your test. So you may want to run the test and then analyze it later on, or you may run a test, save it, make some changes on your gRPC service, run the same test, and then save that again. So now you have two tests that you can compare. So that way you will know whether the changes that you made on your service, on your gRPC service, worked. Let's look at this other one. Let me open this. This one should have a much nicer graph. Yeah, so you can see here, this one is a constant test. It was also tested with the getFeatureAsync method, and we had one virtual user with the invoke interval, so we're really stress testing this, but with no delays in between the calls. And we can see a nice graph over here with three lines, chart in this chart, 3-line series. The green one is for the response time, for the maximum response time. So it's the maximum response over time. And then the bluish one is this one or below is the average. And the other one here, this kind of straightish line, is the 95th percentile. Pretty close to the average, which is very nice. All right, and we were able to serve about, the service was able to serve about 758.91K responses within 5 minutes. All right, so yeah, so that's it. So that's a pretty simple way of running performance tests on gRPC services. Just just configure the test, configure your virtual users, your ramp up time, for constant virtual users, the invoke interval, and the duration of your test, and then just hit run, and then just wait for it to finish, and then you'll get the results of your test. And if you're a developer, this is really useful if you want to do some performance profiling of your gRPC service, because then you can use this to drive the load on your service while you have Visual Studio Profiler running, and then you can immediately see how your how your service is doing, the memory allocation, CPU time, your application timeline, all those things, all those nice things that Visual Studio gives you. So yeah, that's it. So thanks guys, and on the next video I'm gonna try out the burst test, so that so that we can compare it how it looks with a constant test. All right, that's it. Bye.